Okay, so the problem says 5 people start a campaign to raise money for a homeless shelter. So remember, this is 5 people that's starting the campaign, and each day after that, the number of people involved is doubled. So if you read the table here, it says days since the start. Now for this table, I'm going to start with 0 because I will be using the f of 0. Okay, so remember f of 0 is the 0 term, so I'm going to start my table with 0. Okay, so with 0, I have 1, 2, 3, 4, 5. Number of people. Um, so again, what we have is 5 people. Okay, that's the um, number of people starting the campaign. And each day is doubled. So on after day 1, if you double 5, you will get 10. If you double 10, you will get 20. If you double 20, you'll get 40. And each day it just keeps doubling. Okay, last is 160. Alright, so there's my table, pretty much. Okay. So what's important is this beginning right here. You want to make sure you're starting with the correct 0 term. Okay. Notice that a lot of you put um, 1, 5 as your first term. Um, Again, if you read it carefully, it says here 5 people start the campaign. When you're starting something, whether it's a campaign or any scenario, um, keep in mind no day has passed. So it wouldn't make sense to say after day 1, 5 people start the campaign. Okay? Then you are not reading this problem correctly. Alright, so there's the first step. Okay? And from there, I'm just basically using my 2 formulas. And remember, you always want to start by stating the f of 0. Okay, in this case, f of 0 is 5. And I'm going to need that in both places, so I'm going to go ahead and put one down here too, okay? Now, again, I don't really need it for the recursive formula, because the recursive formula, again, is based on the previous term. Now notice that this problem doesn't state or asks you to find a specific term. So basically, when you're writing this formula out, you're writing in just the generic formula that will work for any n term, meaning the n and the f of n will remain n. The only thing I can really figure out here is the r. Remember, the r is the ratio, and if you're going from 5, 10, 20, 40, the ratio is times 2. So what I'm going to do is just replace that. Okay? So f of n equals f of n minus 1 times 2. Okay? And that will be my recursive formula. For the explicit formula, I do know the f of 0 term, that's 5. So again, part of the problem is some of you left that as is. That's something you can substitute out. The ratio, you know, shift button's not working. Okay, the ratio is 2, so I'm going to change that out. The n I don't know, so I'm just going to keep that as is. Let me see here. Let me just do it that way. There. Yeah, so f of 0 is 5. The ratio is 2, and the n is the term that I'm trying to find. Again, they don't specify to find the specific term, so I'm just going to keep the n at that. Okay? And remember, this is a geometric sequence. So if you look at it, notice as the y's increase, I'm sorry, let me try that again. If as the x increases by 1, the y's are doubling, which means they're not, the difference is not the same. Okay, so when you graph it, what you'll get is a sort of a curve that goes up. Okay. So remember, when that happens, we say that well, first of all, this is a geometric sequence, and we call that an exponential function. Okay. All right, let's take a look at the next problem. Okay. This time we have Kayla has $200. She saves $50 each week. So again, I'm going to start with 0 term. So in the if 0 weeks have passed, how much money will she have? That's the beginning, 200. Okay. And let me see. Excuse me. And then from there, I'm just gonna add on 2, 3, 4, 5 weeks, and each time she saves 50. So this would be 250. Then it would be 300, and 350, and then 400, and then 450. Alright, so there's my table. Okay. Again, recursive formula. I'm going to start with my f of 0. So f of 0 equals 200. Okay. Remember, if you don't state the f of 0, you will lose points. And some of you did that. Okay. Um, some of you did not do that, so you lost points. Alright, so we have the recursive formula. Okay. So again, here they don't ask you for an nth term, so you're just figuring out the common difference. In this case, it's going up by 50. So there's your common difference. For the explicit formula, again, I'm going to substitute out, very important, that you substitute out the f of 0. Okay, f of 0 is 200, so instead of f of 0, you want to actually put the 200, okay? Because you're trying to come up with a formula or a function that works for the unknown term. So if you keep it as f of 0, that's not going to help you figure this out. D is the same as before, that's 50. And so really, the n is the only thing you want to remain n. Okay, that way if you are asked to find, let's say, the 7th term, you are ready to plug in that 7 and solve it. Okay, same thing up here. Alright, this time, okay, it's increasing by 50, so therefore it's arithmetic, or arithmetic, depending on how you want to say it. Now, picture this in your head. You're going up by 1s along the x, but increasing by 50s along the y. You will get a steady graph. Okay? So what you have is a linear function. For every change in x, the change in y is going to be the same. So you have the step occurring that creates a linear function. Okay, so there you have it.